Hello, I am Pedro Morales and this is Not So Math. Welcome to my podcast. Today, I want to talk a bit about calculus. It is funny because when I was in college, often people will ask me, so how many calculus classes do you have to take in math? Like 20? Let me tell you something. There is so much more than calculus to math. Actually, the word calculus comes from the Latin word for counting stones or pebble. By the way, in Spanish, whenever you have kidney stones, you say you have calculus. Rather than doing calculations, the modern conception of calculus relies on how you do those calculations. Actually, the great contribution of calculus was the incorporation of the concept of infinity into real-life situations, the so-called actual infinity, instead of the potential infinity. A potential infinity is related to a behavior or property. For example, if you give me a number, I can always find a bigger number, and therefore we say that there are infinite numbers. In contrast, the actual infinity uses an infinite number of things right now. It's a property of a set. Hence, the main difference between potential infinity and actual infinity is the difference between an action of adding more and more things indefinitely and having an infinite number of things right now, unlimited at your disposal. These ideas were first used by Archimedes almost 200 years BC when considering the problem of finding volumes of different solids. Also, Zeno of Elea approached the relation of infinity and the real world by posing many of his famous paradoxes. Many people studied the influence of infinity in calculations, but it didn't gain a formal description until Newton and Leibniz made a step forward in this study in the 1600s. George Polja said, "If you can solve a problem, then there is an easier problem that you can solve. Find it." I think calculus just does this. The essence of using calculus to solve a problem is to realize that the original problem is difficult. It is impossible for me to solve it. Rather, I will look at a small part of this problem, an infinitely small version of it, and solve it. After I solve the simpler problem, I can put all the pieces together, the infinite number of pieces, and glue my solutions to solve the original problem. I can put all these infinitesimals together to get back the original question. Sometimes we don't have to solve an entire problem at once. Sometimes focusing on an individual aspect of the problem can lead to a successful solution for the problem, or as Napoleon would say it, divide and conquer. I think this is the essence of calculus. Thanks for listening and stay tuned for more interesting ideas in a not-so-math way. Until the next time.